We have talked about variables, we have talked about functions a little bit, and we talked about numeric things. We talked about ints and floats and doubles and about booleans. Let me just to finish with this talk about strings, and then we'll probably go over Git and that kind of stuff over and over again. The more you guys use it, the more this stuff will make sense and the questions will get answered. And then we'll talk about I/O. We tend to deal with computers, we deal a lot with numbers, and then we deal with letters, words, right? Words are strings. They are a bunch of letters, one after the others. Each one of the elements of a string is called a character or a letter. It is actually slightly more complicated because computers don't really do letters. They only do numbers. They only do bytes, right? And so what do we have to do? We have to agree the number 23 represents the letter A, and the number 25 represents C, and something else represents capital A, and all those kinds of things. For the purposes of this class, and most of the time in my life, I've been lucky enough to be able to say, I use ASCII, and everybody in the world speaks English, and that's all I care about. If you're going to do ASCII and English, you can deal with 128, so can fit it in 1 byte. If you get more complicated, you can use Unicode, and Unicode is a lot more complicated, but for the most part, you don't care. There's a bunch of languages that don't do 26 letters. They do a lot more. So, for the most part, you can assume that this is ASCII, that these are letters, right? We represent one letter with a single quotation mark. So this would be a way to declare a variable of type char and assign it the letter lowercase b. We do strings with double quotations, and strings are actually slightly weird. We'll talk about them again when we talk about objects. Strings are actually objects, not primitives. We will see Java lets us define our own objects and treats objects and primitives slightly different. But strings are somewhere in the middle. They're actually objects, but we have a special representation for constants for them, and they are immutable. You can never change a string, which means all the differences don't matter between objects and primitives. Again, don't ever use Word or something like that, because it will happily correct your quotation marks and make them mess up your programs, right? So we have strings, we have chars. Many times we have weird characters, like tabs and new lines and things like that. In Java, like in most languages, you use a backslash, not the division, the other one, for marking all the weird things. So /t is the tab character. /n would be a new line and those kinds of things. I tend to use /t a lot because it looks nicer on my screen. Other than that, the only one that you really need to know is /quotation, because that's what you use if you want a quotation character inside your string. For the most part, you never care and you never use quotation characters inside your strings, but sometimes you need to. So just know that this exists. We won't use it much. So if we were where am I? If it was to do JShell, we can do string s equals abc / quotation / tdef. So when we were to print it, it would appear ABC, then this quotation, then a tab, which appears as a bunch of spaces, and then the def. These quotation marks are not part of the string. It is Java telling us that this is a string, or it's JShell telling us that it is a string. Does this make some sense?
Yes.
And we could declare characters, char a equals, what is this? Which character is that? A single quote, right? Does that make sense? What can we do to strings? One thing that we can do is concatenate them. With the plus operator, just like addition. Very similar to addition, right? What other things we can do? And here's why it's important that it is an object. We can do string.length. So if we have, in Java, it is capital S for string. All class names in Java by default start with a capital, so string actually starts with a capital S, rather int and boolean start with lowercase. So we have a string S1 that has the value ABC. We can do dot length. Oops. Just S1 dot length, right? So that will calculate the length of that string, which is 3 because it has 3 letters. We can use equals to compare with another string. Sometimes the equal operator will not work in strings because strings are weird. So you should compare with dot equals for when you are comparing strings. It actually works, but sometimes it doesn't. Rather than figure out when it works and when it doesn't, use dot equals. Compared to actually returns, and this is a common thing to do, what's the result of comparing two things? Right? You get 3 options. Either they're equal or one is bigger or the other one is bigger, right? So compared to in most programming languages, they have an equivalent of this. It returns -1, 0, or 1. So in this case, 0 because they are the same. If we compare with A, S1 is bigger because it's ABC. Oops. It's actually returned bigger than 0 rather than 1. And then if we were comparing with C, we would return less than 0. Not necessarily 0, 1, and -1. Sometimes when you define your own types, you would have to create your own compare to. Which one is bigger, ABC or ABCD? ABCD. These things are actually lowercase and uppercase are two completely different numbers, right? And it happens that uppercase letters are bigger. No, the other one. Lowercase letters are bigger. Keep in mind that 9 as a number is not the same as the letter 9. Does that make sense? So we can probably do this work. Yeah. Oh well. Yeah, you need parse int or something like that to get the things. You can actually do this. You can subtract the letter 0 from the letter 9, and you get the number 9. It's just useful to keep in mind that they are different. And many times this happens also with like floating points or something like that. When you have floating points, Java will eventually, when you print it, it will print something, right? That's not necessarily the same pattern of bits. You can actually control how many decimals it prints and things like that. But that's not the value. The value inside the memory is a bunch of bits. And what you're seeing is one possible representation. So depending on what you do, it may print 4.5 or 4.4999999. And just by seeing the printout, you don't know whether they're the same number or not. We can use concat, which is the same as plus. Substring, and did you notice we use the dot? We use the variable name and the dot and then the method to call methods on objects, right? So we could do S1 is ABC dot substring. Yeah. You pass when do you want it to start at, and then where do you want it to end. And in Java, we start counting at 0. They lied to you when you were a kid. You shouldn't start counting 1, 2, 3. You start counting 0, 1, 2, 3. As a programmer. So now you have better ways to torture your kids. And char at will get you one character at a given position. We won't really use this, it's just, we'll use them later, but just to kind of give you guys a clue for when we happen to use them. We will be using strings, we will not be using many of these methods yet. And actually, I tend to not use this, but I tend to just use plus and convert things, but Java has string.format, which is nice. So let's do this, string.format. If you just pass the string, it will just print the same string. Now, if you do this, let me see if I'm using the right thing. No. There is one magical thing that will make it print the arguments after. I'm trying to remember which one is the magic because I don't use. Yeah! %d is for printing an int, and something like %s would be for printing other strings. So if you don't like using plus for your print lines, you can come learn how string.format works. It's like printf, yes. It's like printf in C, or Python, or all the other places that have printf. There is probably a nicer one, but oh well. I normally just use plus and print everything. By the way, there is slight magic in println, in that it converts stuff to strings. You're really just printing strings, except that it converts the number 1 into a string and then prints it. So you can print ints and floats and things like that. And so strings are special. They are not quite magical, but they have some more powerful juju. Any questions about strings? No. Any questions about functions? No. What we have covered, reasonably cool. Any questions about Git and that kind of stuff? Yes.
What about that get ignored file you wanted us to download?
I have actually added it to your repo now. So if you do git checkout master and you do git pull, it will come.
Okay.
Hopefully. Unless it doesn't.
I missed it. What file did you say?
Git ignore. It's .git ignore. Some of you were lucky and were late in sending me your Bitbucket and registering, so you don't have this problem. The nice people that did this stuff early were the guinea pigs, so I messed up. My script didn't copy. I didn't realize that Linux will not copy dot files. When you copy, you have to explicitly do it, because that's how they hide files. So when I said copy everything in my script, it didn't copy .git ignore, because, well. And what that .git ignore file does is it tells Git, ignore this thing. So for example, you're compiling Java classes, Java files creates .class files. But those, I can recreate them by compiling again. I don't want you to upload them to the repo. And so I can tell Git to not put those. And so some of you, like for assignment 0 or something like that, you had 700 files instead of just one, right? So that file will fix that problem, hopefully. Now, many of you have been doing that stuff, right? A lot of you have done assignment 0, assignment 1. If you haven't, go do it immediately. You are now in trouble. I'm not enforcing deadlines. I will enforce the deadline for assignment 2, and I will enforce it for assignment 1 on them. So by Monday a week from today, or actually Sunday midnight, a weekish from today, you would have to have done assignment 1 and 2. But I'm not going to check whether you did assignment 1 officially on time or not. Just because. Actually, officially, there may be people today that joined the class. If you did that, you're late with assignment 1 now. What are we doing with Git, and what is happening, right?
After we do that checkout and pull and everything, do we have to do a remake, git make, or again?
Make Eclipse, or
Yeah.
you shouldn't have to. You shouldn't have to. But sometimes, yeah. Depends on whether you check them in or not, or something like that. I think if you check them in, then when you go back to master, they disappear because you just checked them in.
Yeah.
And so you'd have to do it again.
That's not
Yes. If you, now that you kind of know, you can run them individually. You can go to the folder and run make eclipse on that folder. So, yeah. You end up doing several things, right? First of all, basics of commands. How do commands work? They work almost like English. You give a command, you give an order, you give a verb, right? Do stuff. The commands that we have been using are cd for change directory. Directory is what folders used to be called before Windows and Mac started calling them folders. Right? That's a way to organize your file. mkdir is make directory. And for the most part, you give the command and then this stuff. So you say, do this, to that, and that other thing, right? So you do cd and you go different places, right? home/documents, projects, class, okay. So this is the command, cd, and this is the argument or parameter. This is the go do that, right? This is the direct object. And sometimes you do magic for indirect objects. That's what we are doing with Git, right? Git is our command, and then we tell it what else to do. So Git kind of has its own language, almost.
Is there like a quick way to bring up like a command list? Like some of them have like where they'll pop up like the top, like just like the quickest
The thing is, if you press tab, it will give you the list of commands. But there is, on my Mac, there's 826 possibilities.
So there's like no quick list or anything that it comes up? Okay.
No. You can, if you know the name of the command, you can type man. And the command, so man cd will give you. But to tell you the truth, Google is a lot better than man.
Well, I just know like depending on what you're using, sometimes it'll just bring up like a quick, you know, certain command.
You can do -h to most of the commands and they will tell you.
Okay.
But you need to know the command.
Yeah.
If you don't know the command,
Google.
Google, yeah. Actually, there is apropos, which looks at all the man pages that mention that word that you say.
Oh, yeah.
So,
I feel like Google does that just a little bit.
exactly.
A little more.
Google does all this a lot better. It is nice to know that it exists for when you are stuck without a network, but Google does it a lot better. If you are stuck without a network, you have your phone. Google it on your phone. That's probably better than trying to do these things. I mean, they're good to know. If you ever go take the Red Hat exam, it'll be useful. But other than that, Google is a lot nicer than these things. I tend to do the -h. So there's a bunch of commands where I know the command, but like cp for copying a file. Which one goes first? The source or the destination? It's like, I mean, that one I know because I use it all the time, right? But it's like, is it like an assignment or the other way around? Because both would make sense. And so I tend to do -h or -- help. But actually, in this case, it's just complaining. But
Either, yeah, is it
Yeah.
question mark? Because I can see question mark.
MS-DOS used to have, no, they don't have any.
I don't know how, at least not in that.
Many of these commands are actually programs, right? That somebody else writes, and so depending on who writes them, they may have slightly different convention. -h tends to be common, and -v for verbose, for telling you a lot more than you ever wanted to know, tends to be reasonably standard, but by the way, you should now be terribly scared because I've been forcing you to use Linux. Ooh, It's Bash, it's not Linux. But that is what you use for Linux. So you're learning Linux. Sorry about teaching you stuff. I won't do it again. It's not that complicated or anything like that, right? It's just one more shell. But it does take a while to get used to this idea of the command, right? If you have never done this kind of stuff, you get really used to touching, right? Using your mouse to touch things on the screen, and you don't really think too much. Here, you have to type the command. When we're doing Git, Git status, I type it like 700 times a day. That just tells me where I am. Actually, on Git Bash, if you're on Windows, that is actually slightly nicer because it shows you the branch name anyway. But I always do this because I need to know which branch I'm on, right? I tend to ask you to do things like this. Git checkout -b creates a branch. Let me change something. So I just created a file. So if I do git status right now, it's going to tell me you have one file that hasn't been committed, hasn't actually been added, right? How do I do to add it to the commit? What do I do? Git add, right? So now git status will show that it has been added, it would be committed, right? What do you mean by delete that file? Remove it from the branch, git rm, once you have committed it. If you haven't committed it, what you want to do is git reset head that says, oh, undo my changes. So that brings it back to how it was, and then you could delete it. Once you have added it to your whole thing, then git rm will delete it. Sometimes just removing it may do it, but you have to tell special things to Git so that it gets removed on the remote. If not, it will just stay on the remote place. So you would need to do git commit and then some message. Actually, for some of you, in different conditions and different ways, it will ask you to set up your username and email, right? So it asks you to do something like config global or something like that. No?
It only does it the one time, right?
It does it the first time, and if you do it, it gets done. In some cases, depending on how you have set up your machine, it will recognize your username from the system. And so it will not ask. Depends on what's going on. Yeah, and then it will do it just the one time. Another thing you can do is git branch, and that will show you which branches you have and which ones you're on.
How would you change branches from here?
Git checkout master. Like this will get me back to the master branch. And kind of the first thing that you do when you start a new assignment should be cd to the folder, right? Then git checkout master and then git pull. Just to get whatever ended up being in master. Just so you start from master and you do smaller changes. If not, every pull request will include your changes to assignment 0, 1, 2, 3. This way.
How to pull without override the work that we have done?
Those are contradictory things. Pooling is overriding the work you have done.
Because, for example, we have done assignment 1. Next week we're going to do assignment 2.
Yes.
So when I pull it, it's going to just...
Yes and no.
Yes.
You do git checkout master, so you change to the master branch. Assignment 1 branch is still there,
Oh, okay, I see.
right? So pooling overrides, and that's what you want. You want your master branch
But overrides master.
overrides master.
So the branch A1 is going to keep intact.
Exactly.
Okay.
That is the point of Git, but that's a very good observation. The other thing that you're going to be doing here is going to the individual folders, right? And in here we do gradle and either test or grade. Or actually Eclipse. And what this does is creates the Eclipse project. So if somehow your Eclipse gets messed up, you can do this and it will regenerate the project. And kind of make it point to the right Java version. Maybe. Never mind. I thought that I had added the one for IntelliJ, but I didn't. Any questions about Git and commands and stuff like that? Now, pretty much not the only difference, but the main difference between doing it like this and doing it on Windows is that on Windows your background is black. Other than that, it's the same thing. Okay, so, and feel free to keep asking questions about this stuff until it makes sense. Now let's talk about full programs, and we have cheated because we have actually sort of created them, but right? You officially were running the test and you didn't know what you were doing. Many of you did, but you didn't have to know what you were doing. Most of the programs, right? What you want is to take some inputs, do something to them, and produce outputs. For simple programs, we read the input from the user directly, we read from the keyboard, and produce output to the screen, right? When we store information, we store it in variables, right? Traditionally, the first program is Hello World. I hate it, because that one doesn't actually have inputs, right? So it's not a very useful thing. So I do the equivalent, right? But slightly more complicated. I ask, enter your name, I read it, and then I print hello and the name. So this is a lot more complicated than Hello World. There is one horrible thing about Java. It is a 20-year-old language. So when they started doing it, they didn't know how to read from the screen, from the keyboard, right? They had some things, and there's like 3 different versions of how to read. Eventually, they came up with the scanner class that is reasonably useful. It sort of kind of works. But they first created system.in, which is an input stream. And so we normally create a scanner from that system.in. This is another example of an object. So we create a variable type scanner. What's the name of that variable? Input. And we set it to be a new scanner, and we pass as a parameter system.in. What does that give us? The ability to do stuff like input.nextLine. And that just reads a line from the keyboard. So even without Eclipse, I can do this class, right? And I have one file, hello.java, java c hello.java, and then java hello. Please enter your name, Orlando. Woohoo! Really cool, complicated programs. We normally use either Eclipse or Gradle because eventually we end up with slightly more complicated programs with 3 files instead of 1, right? In real life, you normally have probably hundreds of files, even in a simple project, right? So that's why we need Gradle or Eclipse or both. Couple of other things. What is this weird import statement? The full name of that class is java.util.scanner, right? Java organizes its code into packages, which are basically like folders in your hard drive, right? And so the full name is java.util.scanner. You can do either of two things. Either write the full name every time you need it, or use an import statement. The simplest way of an import statement is like that, and that just says, okay, whenever you see scanner by itself, I name java.util.scanner. Does that idea make sense? It's like establishing a context. Whenever I talk about Joe, it's this Joe. Not everybody else, right? And so that enables us to here write just scanner and scanner. Then we get to noise. Public class hello. For now, assume this is noise. We will talk about what it does, but the only important thing about this noise is that it has to have the same name as the Java file. So if your class is hello with capital H, what's the name of your Java file? Hello.java with capital H. Does that make sense? And then we have a main method. Public and static assume that they're noise. Actually, the whole thing is noise for now. We'll definitely go through it, but this is where your execution starts. So it's gonna go there and go do whatever you tell it from there. All the other stuff that you define is not executed unless it is called from main. Does that idea make sense? And then we had talked about this stuff, right? We create our scanner variable. System.in is, we have a system class and we are accessing a variable from the system class that's called in that has a reference to the keyboard or the standard input. Not quite a keyboard, but for now, think of it as a keyboard. And system.out is the standard output. From our scanner class, we can ask next line and also stuff like next int or next double. And it will parse and do the right things for us. Now, let's make it slightly more interesting. Imagine that we may want to define a function because we don't know. Maybe we want to change how we say hello. Maybe we want to say, I don't know, I'm not a native speaker, hi. Or what's up, right? That kind of stuff. So by encapsulating it here, right, I'm always calling the same function, and you can change the implementation. The main will look the same, but you can change it, right? It is way overkill for this, but I really like this idea of your functions have all the parameters they need, and they never touch anything else. So I define my function taking the name and a print string. That is something that I can print to. That is something that I can call println onto. Does that idea make sense? And so rather than doing system.out, I do out.println. I use string concatenation and magic. Hello, name. Notice there's a space here, because if you don't put spaces, then string concatenation doesn't add them for you, right? God. I just got confused in my code. Okay, let's look at it this way. I have no clue what's written here. I'll change it. I'll fix it. I promise. We'd have a function say hi. We'd have a function get name from user, right? That we are passing it a string, a print string out. We are passing it a scanner, and we are calling that scanner in. And this function is horrible. Should call out.println, not system.out.println, sorry. And then call next line and return that call thing. Does this make some sense? So now our main looks a little bit nicer. I just call get name from user and then call say hi. For something this simple, this is definitely overkill, but, right, it makes your life slightly easier. If you think about this thing, right? Here we have 2 lines, here we have 1. And the intent is made clear by having a nice name. 2 lines versus 1, you probably shouldn't be creating functions. But when you start having 5 lines versus 1, then creating a function makes your code easier to read, right? And easier for the poor sod who's going to come and maintain it next to maintain. And you know who's that poor sod, right? If you, again, in 2 months, when you come and say, who the hell wrote this piece of manure? Oops, Git tells you, you committed that stuff. So you better treat your future self right. Let me just mention, that is cool. Woohoo! This is nice. We are done. We get to play more, but let me actually open it here and talk about assignment 2. Because you're going to be, basically, you're being asked to do this kind of stuff, right? Over and over. I normally give you an example. So this is read and double. This function reads a number and returns twice that number. So I get passed a scanner and a print stream. Print to that print stream. Read from the scanner. Return twice that. And then I'm asking you to do really complicated stuff. Read two numbers and add them. Return the addition. Return the sum. Then read two numbers and multiply them. And then in this one, you get two numbers and you need to print all 5 operations. Sum, difference, product, quotient, and remainder. And then in main, I'm asking you to create a scanner, call read and add, call read and multiply, and then call print all operations. It should be really easy, right? Should. Cool. Any questions? How do you call a function? You would write the name of the function and then the actual arguments that you want.
Do you write it in there? The arguments that you want in there?
Yes, so imagine that we have a function. Let me get back to the shell. Maybe. Or actually, let me do it in Eclipse. Because that way, let's do it. Let's do it here. In main, right? Oh, did I mess it up? Yes, I did. Oh, one sec. Oh, this is good. My Eclipse got messed up. Now I think this would work. It was working. We can do it this way. I have no clue why my Eclipse got messed up. Again, I tested it, it worked. Not anymore. Now, this is the function that I'm going to call, right? Read and double. I can call read and double. That is one way to call the function. By the way, I think for this kind of stuff, create a scanner variable, because if you create two scanners for system.in, system.in gets confused. It may not keep in sync between both of them. Now, normally, when you call a function, you want to do something with the returned value, right? So we could do something like int d equals read and double, and then system dot something like this. So now when we run it, nothing happens. Find the right place. This guy is not on the right place. Yeah, okay. I have a different, this is a different thing. It's modifying the wrong folder. And that may be why everything was broken. Oh, and I undid all my changes. I have no clue where I was editing. So, let's edit it again. I have so many copies of this stuff on my computer that I was editing one wrong one. Even though I end up making a lot of semicolon mistakes when I create your repos and things like that, I test them over and over. It's just that it's a lot harder to test when you know what you're doing. It's hard to be a computer. So we did int d equals read and double in system.out, and then system.out.print. Enter number 12. You get double digits 24.
Where you put int d equals the function, what are you defining the? Where was the function originally?
Here.
Oh, okay.
And remember, this noise needs to be there. Same as in main. We'll explain what the noise really means, but for now, know that it is noise, but put it there. Notice that this is calling of a function, right? This is what calls the function, right? The name of the function and pass the arguments, right? And then you also have this other build that you normally can do int the name of a variable equal, and then whatever expression that returns a value, right? And so it just happens that our expression is calling a function. Does that make sense? Do we want to play with writing more functions? Do we want to play with more I/O?
So where is the system.out method? Is it coming from the scanning?
No, system.out is a piece of system. System is a global class that I have access to, right? Has two pieces that we know, in and out. So system.in means the in piece of the system class, and system.out means the out piece of the system class.
So it just prints the output of the screen.
Well, I'm passing system.out to this function, right? and then this function is calling out.println. So this is the same as system.out.println, basically. And that by default, unless you do magic, prints to the screen. Does that make sense? Any other questions? No.
And you don't need to import system, right?
I don't need to import system because system is already just system. Doesn't have a short name. Doesn't have a really long name, so I don't need to make it any shorter.
But does it comes from the library as well?
It is from the library itself, yes. I think it is maybe Java something or another, but it is imported automatically. There is a couple of automatic imports. So they import a bunch, like string. String is actually somewhere. String is java.lang.string, but it's already imported for you. So you don't have to do import for string. You don't have to do import for system. And again, how do you get documentation for these things? Sun's website is really nice. Oracle's website is not Sun anymore. But actually, I normally Google stuff. Java system. Woohoo! And after you get to documentation from Oracle or Sun or whoever, but I normally Google it first. You will realize that after this class, you never have to use Google again for Java. Why aren't you laughing? Google is your best friend. You still Google that stuff, right? All the time. Actually, you Bing it. Okay. I used to work at Microsoft. I still have Bing as my default search engine. We only used it as a verb as a joke, although we worked in Bing. It's still, right, that kind of reference stuff, you don't memorize it, you memorize the stuff that you use. You probably know system.in and system.out, but it's like, what other things does system have? What's the full name of systems? Actually, java.lang.system. But you don't have to import it because it automatically imported for you.
It's okay to put the explicit name?
Java.lang.system? Absolutely. I actually, other people are very, very picky about never writing the full name and always importing. They think to feel that it's kind of ugly to write the full name. I tend to feel that not having to Google things is good. So I tend to write, for a program like this, especially if it's something that I don't use all the time, right? I mean, you probably use Scanner, but if I was gonna do a simple program like this one, come thingy. Most people would actually do the import, but it's like, okay, I'm referencing this only twice. I would rather write java.util.scanner twice, just because that means that when I'm Googling that thing, I'm Googling the full freaking thing. So I tend to normally write the full name and then be beaten down by my coworkers and going to delete it and importing the stuff to make it adhere to the team standards, which is a good idea. It's just, I tend to do that a lot more just because I like Googling specific things rather than there may be 7 scanner classes in different libraries. But it is perfectly okay to write the full name. It's just,
They don't like it.
yeah, it's style and kind of laziness. Which kind of laziness do you prefer? And it becomes, for something like scanner, chances are that after the next week you would never have to write the full name. You just cut and paste import to each one of your programs. But cool. Shall we? Let's try to make one more function just for fun. And modify this stuff, right? Multiply by 2. What do we return? And then what can we do on this one? Woohoo! Maybe. Ah! Noise. So now I just did the same thing, but I did it more complicated. It's a predefined method of the scanner class that just reads from the keyboard numeric, it reads digits and converts them to an int. So it reads the digit 1, then the digit 2, then the digit 3, and it converts it into the integer 123, or 123, sorry.
It ignores other characters.
It stops when it sees something else. So what happens if I do it tells me there was no int. It would be okay if I do oh no, need to do space. Eventually you end up parsing this the right way and figuring out what should you do if they wrote one Orlando rather than one space Orlando and things like that. But for the simple programming we are going to be doing, it is okay to just break. By the way, you looked at exceptions, which eventually we'll talk about. So chances are that you will see some of these kinds of things, and that just tells you something went wrong. The good thing is that eventually it tells you which line in your program messed up. So it's telling you, you don't know, but all of this happened, right? Your main function called read and double, which called next int. Now this next int called this other next int, which called this other next. That's their internal implementation, I have no clue. And then eventually died and called throw4. This is called a function stack. And when you're doing function calls, that is happening. A stack is being created, a function is called, gets put in the stack, and eventually they get unstacked as you're returning. And
So it goes from the bottom up.
yes, this is the first thing that happened. That was main. Main called read and double called next int, which called this other next int, which called this one, which called this one. Yeah, this one is probably the one for throwing an exception. So normally if you're calling libraries and things like that, you look at the bottom couple that tell you your code, and then all the other stuff is like, okay, I'm not gonna go debug Java standard library. Any other questions? Yes.
How come you don't have to set a default?
A default what?
A default, I don't know, string or so for them, so say you didn't throw in a number, you threw in for multiply by 2, say you threw in a string
Oh, well,
as a response.
the thing is that what would happen if I can call here multiply by 2 Orlando, right? What will happen is Java will not compile. Let me move that window. Why? Window. Where is that? Show view. Error log. Oh, this is beautiful. Not this one. If I try to compile, it will tell me, where is it? It will tell me the error. It doesn't let me. Problems. And it's tell me, right, multiply by 2, you cannot pass it a string. So on Java is a statically typed language. It will check and make sure that you're passing the right kinds of values. It cannot detect all errors, but it can detect a bunch of them. So it's sometimes good to have bondage and masochism. And it would let me do this. I don't even think Java has default values. Maybe it does now. For the longest time it didn't. Any other questions? No? I'll give you back 5 minutes of your life. Or 10 or something like that. 5 minutes of your life. For Wednesday, bring your laptops. Make sure that you bring your laptops, and we can actually, at least for a little while, do assignment 2. Finish it here. If you have problems, we can address the problem. Sorry?